Let me share it again. Yes. Is it okay? आप लोगों को ये स्क्रीन नजर आ रही है ये वर्ड का कि नहीं? Raise your hands. Okay. So we have to prove that both beta 1 hat and beta 2 hat are linear functions of the yi. So for that, we have to start from the two variable regression model. And as we know that beta 2 hat equal to summation xi minus x bar yi minus y bar and divided by summation xi minus x bar square. This is the beta 2 hat formula. We already derived it with the method of ordinary least square. So here we have the value of xi. Here it is, that is summation xi minus x bar whole square. Now beta 2 hat equal to summation. Now we have to multiply this yi, this one, with xi minus x bar. So we have summation yi x minus x bar. And we have to also multiply y bar with the summation xi minus x bar. So we have yi into xi minus x bar, and we have minus, I need a bracket here. Yes, this is minus. समेशन नाउ ये वाई आई जो है ना, ये वाला ये एक्स आई माइनस एक्स बार के साथ मल्टीप्लाई हो गया, इसी तरह माइनस वाई बार जो है ये भी एक्स आई माइनस एक्स बार के साथ मल्टीप्लाई हो गया and divided with the same term, that is summation xi minus x bar square. Now beta 2 had equal to summation yi xi minus x bar. This is xi. This is xi minus x bar, and the second term, that is this one. This is summation xi minus x bar, and summation xi minus x bar is equal to 0. So this term will be equal to 0. This term, this one will be equal to 0 because of summation xi minus x bar is equals to 0. And in denominator we have summation xi minus x bar whole square. Now beta 2 had equal to summation capital yi this I in a subscript. So this I in subscript. Capital Y xi minus x bar. So we have to put the small xi, as I told you that small xi, that is the deviation from small xi that is equals to capital xi and minus mean of capital X. So here it is xi minus x bar. This is small xi. Similarly, in denominator we have again xi minus x bar. So we have to put the small xi on this one. So the above term can be written as summation yi small xi and divided by summation small xi square. So beta 2 here has been expressed in the deviation form. Now summation wi yi, where wi equal to xi divided by summation xi square. W यहाँ पर हमने W लगा और W जो है ना वो इक्वल है किसके इक्वल है एक्स आई और डिवाइड बाय समेशन एक्स आई स्क्वायर के। अब अगर आप W की जगह ये टर्म जो है ना ये अगर आप लगाएंगे ये वाला टर्म, इफ यू पुट दिस वन इन द अबव फार्मूला, अगर आप W की जगह ऊपर ये लगाएंगे W की जगह तो आप देखें एक्स आई डिवाइड बाय समेशन एक्स आई स्क्वायर आ जाएगा और ये आपके पास जो ऊपर वाला टर्म है ये वापस आपको मिल जाएगा। तो यहाँ पर इस दिस इज जस्ट फॉर द सेक ऑफ द सिंप्लीफिकेशन। तो अब यहाँ पर आप देख सकते हैं कि बीटा टू हेड जो है दैट इज जो है ना वो डिपेंड कर रहा है किस चीज़ पे, वाई आई पे। जब तक आपके पास वाई आई के वैल्यूज ना हो तो तब तक आप जो है ना वो बीटा टू हेड को फाइंड आउट नहीं कर सकते। तो इस वजह से हम कहते हैं कि बीटा टू हेड जो है वो डिपेंडेंट है वाई पे। सिमिलरली we have to prove the same property for the intercept one, that is for the beta 1 hat. Now beta 1 hat जो है वो इक्वल होता है y बार माइनस बीटा 2 hat x बार के, और ये इसका जो प्रूफ है वो मैंने आपको सेंड भी किया था कि after minimizing the sum of square of residual and taking the partial derivative, we prove that beta 1 hat equal to y bar minus beta 2 hat x bar, and note that this y bar is actually capital Y bar and this x bar is capital X bar. These are not in the deviation forms. Now again, y bar is equal to summation y divided by n. So we have to put it here, and minus beta 2 hat, as it can be seen from the above equation, that beta 2 hat equal to summation wiyi. So we have to put this value over here. That is summation wiyi and x bar. As it is clear now that x bar, this is actually in capital form. Now summation I from 1 to n. Now we have to take yi common from the above equation as well as the summation sign. So keeping summation and yi, capital Yi out of the brackets. So we have 1 over n minus x bar and wi, and जो y यहाँ पर और जो y यहाँ पर that has been out is a common. So beta 2 hat that is equal to summation 1 over n minus x bar wi yi. So this is which completes the proof that b1 hat also depends upon the value of yi. Until you have the value of yi, you cannot find out both the beta 1 hat and beta 2 hat. So that is the first property of the OLS, or this is the first property of the Markov theorem, that both the beta 1 hat and beta 2 hat, that depends upon the values of y. Now we have to prove the second property. Let me show you that where we left it yesterday. That is the second property. The first one has been cleared, that is both beta 1 hat and beta 2 hat is linearly related with the yi. Second, it is unbiased. So let's start again the property number 2 of the OLS estimator, or of the Markov theorem, that the least square estimator beta 1 hat and beta 2 hat are unbiased estimators of alpha and beta. Let me clear here, this is actually beta 1 and the second one is beta 2. So we know that from the first property that beta 2 hat equal to summation I from 1 to n wi. So summation I from 1 to n wi, and what is the value of capital Yi? As I mentioned in the very start, that we are studying the two variable regression model. So yi equal to beta 1 plus beta 2 xi into epsilon I, or it is also known as the population regression function. I write down it over here. The difference between just this one and the later one is only we denoted with the error term with ui, just like in the book, but here it is denoted with the epsilon I. These are just notations. Otherwise, the meanings of both epsilon and ui are same. Now, beta 2 head equal to summation I from 1 to n wi capital Yi. So, summation I from 1 to n wi and yi equals to beta 1 plus beta 2 xi plus epsilon I. Now, straightforward, it's just a multiplication inside the brackets. That is beta 1 multiplied with summation wi. wi जो है ना वो सब के साथ मल्टीप्लाई हो जाएगा, प्लस बीटा 2 वो कांस्टेंट है, वो समेशन से हमने आउट रखना है क्योंकि कांस्टेंट पे समेशन जो है ना वो यूज नहीं हो, तो प्लस बीटा 2 आ जाएगा, समेशन wi xi के साथ मल्टीप्लाई हो जाएगा, और लास्ट पे wi जो है वो एप्सिलॉन के साथ भी मल्टीप्लाई हो जाएगा. सो वी हैव इक्वेशन नंबर 1. नाउ हम थोड़ा सा जो है ना वो समेशन wi को देखते हैं कि ये किसके बराबर है. समेशन wi इक्वल है समेशन, और wi किसके बराबर है, वो बराबर है xi डिवाइड बाय समेशन xi स्क्वायर के. ये ऊपर हमने डिफाइन किया था ये वाला कि समेशन के wi जो है वो xi डिवाइड बाय समेशन xi स्क्वायर के बराबर है. सो यहाँ पर इस समेशन w को हमने देखना है कि इसको थोड़ा सा हमने एक्सप्लेन करवाना है मैथमेटिकली. तो समेशन wi जो है वो इक्वल है समेशन xi डिवाइड बाय समेशन xi स्क्वायर के. अब यहाँ पर जो xi जो है वो डिविएशन फॉर्म है, और इस डिविएशन फॉर्म को हम एक्सपेंड कर सकते हैं. दिस इज अ डिविएशन फॉर्म, दिस इज स्मॉल xi and this small xi is equal to capital Xi and minus x bar. So we replaced small xi with the xi minus x bar. Sorry. So let me write down again. Xi minus x bar is xi minus x bar divided with summation I from 1 to n and xi this is xi n square. Yes. So and this is equals to 0 as summation xi minus x bar equals to 0. So summation wi is equals to 0. Now we have to also find out that what will be the value of summation wi square. So summation, and we have wi square, just squaring the value of w, which can be seen in the equation number 1 or equation number A, that summation w equal to summation xi divided by summation xi square. So the value of w is xi divided by summation xi square. So just put down xi divided by summation xy square for the value of w, and as it can be seen that this is summation, sorry, this is w square. So here is the square as it is. So summation, because of this square, this xi will be square. So we have summation xi square. This is summation x square, and because of this square, we have summation x square whole square, which is equals to, by applying this summation inside, so we have summation xi square and divided by summation xi square whole square. So in the denominator, we have one summation xi square, and in the denominator, we have two summation xi square. So one will be cancelled, and we have only 1 over summation xi square. So this is our equation B. Summation w, that is 0 in the equation A. Summation w square is equal to 1 over summation xi square. And in the third case, we have to find out that what would be the value of summation wi xi, which is equals to summation I from 1 to n. Again, what is the value of wi? This is xi divided by summation xi square. And what is the, sorry, and multiplied with the xi. So this is equals to summation xi and xi. So this is summation xi square divided by summation xi square, which is equals to 1. Now putting these values in the equation number 1, beta 2 head equal to beta 1. Look at the equation 1, summation w, and from equation A, it is equals to 0 plus beta 2 summation wi xi. So summation w xi, sorry, so this xi is actually in the capital form, and we write it as the small xi. So we need to clear it first, that what will be the value of summation wi and xi. So it is written over here that summation wi, it is xi minus. So let me explain over here. Actually, this is not the small xi, but rather than it is the capital xi. This is the capital xi. And when we put xi, yes, so again this will be capital xi, and after expanding the small xi is actually capital Xi minus x bar, and we have also the capital Xi, and divided by the summation xi square minus x bar summation xi. So this is equal to summation. We have 1x and 1x, so we have 2x, and that is square square minus x bar. Let me first clear it. I will explain it to you. Don't worry. This is very simple, but here is a small mistake of using of capital Xi instead of small xi, and we have summation x. So summation xi square minus x bar in summation xi, and what was its value? That is, it is equals to, in the denominator, now work on the denominator. In the denominator, after expanding the small xi, we have xi minus x bar whole square, and after expanding the term in the denominator, we have summation, we have summation xi square and minus x bar plus x bar square, that would be nx bar square after applying the summation, and minus 2 times nx bar. So nx bar and nx bar, we have minus nx bar in the denominator. Just expand the square formula, you will get this one. Just expand the denominator, the square formula, that is, we will get summation xi square plus x bar square minus 2 xi x bar. Now after applying the sigma sign, so we have summation xi square plus, after applying summation on x bar, we have nx bar square and minus 2 nx bar by, so we have plus nx bar square and minus x bar square, so we have only minus x bar. So nx bar square summation xi square plus nx bar square, so we have minus nx bar square minus nx bar square, so we will get this one, which is further equals to summation xi square okay. So we have summation x square minus nx bar square, because summation xi is equal to nx bar, so we have already 1x bar. Now by putting nx bar instead of summation xi, so we have minus nx bar and divided with the same term of this one, summation x square minus nx bar square in the denominator. Let me write down again by entering the Microsoft equation 3 from the word. So we have summation, xi square minus nx bar square, this one, and that is equals to what? Because if you look at the term in the numerator and the denominator, both are same. So summation xi square minus x bar square divided by summation x square minus x bar square, they are same. So this is equals to 1. Therefore, now putting all these values in equation 1, that is beta 1 summation w is equal to 0 plus beta 2 summation w xi, which is equals to 1, that is summation. So there is no need to write down here. This is summation wi and capital Xi, this one. Yes. So beta 1 summation w is 0 summation w xi plus summation w epsilon I, beta 2, and this is equals to 1, as it can be seen from the above equation that summation wi and capital Xi is equals to 1. So we have beta 2 n plus summation wi xi. After taking expectation on both sides, that is expected over beta 2 equal to beta 2 plus summation wi applying expectation on ei. Because in the w we have only the values of xi, so expectation cannot be applied on the wi as it is the function of xi, and we started that xi will be not random. So expected value of beta 2 had equal to beta 2, and by the assumption E of epsilon I is 0 or ui is 0, which completes the proof beta 2 head is a unbiased estimator of the beta 2. Okay, just let's break after 5 minutes, then we will back.